This is on page 251. I want to do some highlighting here. First of all, when you have a y and an x squared, we call that a quadratic function. Have that in the box right here. What you did in grade 10 were linear functions. When you just had the highest degree was just an x to the 1, those are linear. When the highest degree is an x squared, that makes it a quadratic function. And we call the graph of a quadratic function a parabola. When you have it in this form, ax squared plus bx plus c, we call that the general form. Some more highlighting. So I said, what do we call this graph? This graph or this curve is called a parabola, and it has some characteristics. The point where it changes is called the vertex. The vertex is either a minimum point or a maximum point. Parabolas are always symmetrical. They're the same on one side as the other side. And that's because what does an x squared do? Right? If you did x squared of 3, you get 9. If you did x squared of negative 3, you also get 9. So it has that symmetry because of the x squared. And so we can draw a dotted line called the axis of symmetry through the vertex. That cuts your parabola perfectly in half. And a parabola is always a perfect reflection over that line. It is symmetrical about that line. We sometimes say a graph opens up, and sometimes we say a graph opens down. So this one's not a highlighter. Let's try that again. This one opens. Patience. This one opens up. This one opens down. When you graph it, you're going to have to make sure you put arrowheads on the end of your graph to say it goes down forever. And we can tell that a graph is going to open up when whatever's in front of the x squared is positive, it opens up. Whenever what is in front of the x squared is negative, it opens down. Things that open up have a minimum. Things that open down have a maximum. Does it make sense that the domain is everything? There's no number you're not allowed to square. You can plug any value of x into any parabola. But the range is going to depend on where your vertex is. Because you're unlike a line where the range was everything, the range of a parabola isn't everything. It depends on your vertex. Okay, so with that, we can go to example number 1. And we want to graph this, and we have no shortcuts yet. So the only thing you can do without a shortcut, and never forget this strategy, because this is a super important strategy. It works for any graph at any time. You can use this strategy to graph x cubed graphs if you want x to the 4 graphs. You have to do those next year, x to the 5 graphs. We can figure anything out if we have a table of values. So what I'm going to do is I'm going to draw my graph here. And if I plug in one x value, and I always like to start with things that make my mental math easy, I like to choose 0. If you plug in 0 for x, can you see that you will get -6? So 1, 2, 3, 4, 5, 6. That's my first point I can label. 0, -6. Other things that you think would make your mental math easier? 1. I like the number 1. So I plug that in. By the way, Do you feel confident after having 1 point that you know what this graph looks like? I hope or not. Right? I still only see 1 point. Not very confident yet. So I plug in another point, I get 1. And if I plug in 1 in for x, I would have 2 plus 4 is 6, minus 6 is 0. So on my graph, when I plugged in 1, I got 1 comma 0. And what we're going to do is we're going to keep plugging into points until we find symmetry. Because we know that we just saw all parabolas have an axis of symmetry. If you find out where the symmetry is, you're going to be able to say, I know a bunch of points a lot quicker. I know where the vertex is going to be. And I think I'm going to draw this graph fairly accurately. But we're not there yet. What would you like to plug in next?
2.
2. 2 squared is 4 times 2. This will be 8. Plus 8 is 16. Minus 6 is 10. Way up there. 2 comma 10. What would you like to try next?
3.
Okay. We can try 3. I don't like 3 next, but I'll tell you why in a second. 3. 3 squared is 9. Times 2 is 18, right? 18 plus 12 is going to be 30. 30 minus 6 is 24, okay? What's the problem with that point? It's off my graph. I can't even do it. It's warm in here already, and now I've jumped. I'm like, oh, good. What? So, yes, we could do 3 and 24, but that's a little bit problematic because it's gone up so much. So what would you like to try next?
-1.
Negative 1. If I plug in -1, -1 squared is going to be positive 1 times 2. This will be 2 plus a -4. -2 minus 6, -8. -1, -8. Have we hit any symmetry yet? No. -8. So what are you going to try next? Wow. When I jumped, I muted my mic. That's impressive. That means I jumped. You didn't see it. You won't ever see this in the video. So I jumped really, really high. Like you had to experience that in class. I just narrowly missed my head on the roof there. So, okay. We'll try -2. -2 squared would be 4. 4 times 2 is 8. 4 times -2 would be -8. 8 plus -8 would be 0. Minus 6 will be -6. And for the first time, I'm going to get excited here because I have just found my symmetry. You see, you've got -2 gave me -6 and 0 gave me -6, which means if I take out a dotted, I take out my red pen for my axis of symmetry. This must be my axis of symmetry. And because it's my axis of symmetry, I can do some things a lot quicker now. Without even plugging things in, I know that I am going to have -3 comma 0. You see how I did that? By symmetry, this is 2 away. By symmetry, that would have to be 2 away. I can move up here. And instead of 2 comma 10, which is 1, 2, 3 away from here, 1, 2, 3 away from here, I'm going to have -4 comma 10. And I can draw my U-shaped parabola through those points. And that's a very accurate graph. So your table of values, you have to keep doing until you get symmetry. And then you can repeat the points you had on one side on the other side, and you can get your parabola. And whenever you find the symmetry, you know that your axis of symmetry, in this case, it is at, we can label it, at x equals -1, because all the x values on that dotted line have an x coordinate of -1. We can draw our graph. Sometimes your axis of symmetry is going to be not at the perfect number. Like it might be at 2.5, and then you'd have to plug in 2.5 into the equation to actually find the vertex. That would be a little bit annoying because it's a decimal, but it could be done. So, we've sketched the graph. Now, could you tell me what the intercepts are? Okay. Well, you have two different kinds of intercepts. You have x-intercepts. They happened at -3, 0 and 1, 0. And you have y-intercepts. Well, you only have one of those at 0, -6. So intercepts are x-intercepts and y-intercepts. Mathematically, if someone says, just find the y-intercept, what always happens on a y-intercept? The x value is 0. Can you see? That's why we chose that as our first point. It was really easy to do that mental math. If someone says, find the x-intercepts, you would plug in 0 for y. And if you plugged in 0 for y, I'm going to do it in green right here. It's a chapter 3 question. How do we solve quadratic equations? Factor, by square rooting, or the quadratic formula. This one I would definitely factor out a 2. That's common. And then it has to be x and x, 3 and 1. It's going to have to be a +3 and a -1. That'll give me x equals -3 and x equals 1. Those are my x-intercepts. Notice those showed up right there. And if you find your two x-intercepts, if you did that as your first strategy, you found symmetry. Because there's always going to be symmetry. So if you had found -3 and 1, halfway in between those, -1, is your axis of symmetry. So that might be a shortcut that we use later to help us find the vertex. What is the coordinates of our vertex? Coordinates of our vertex were at -1, -8. Our axis of symmetry is x equals, it says an equation, so you have to have an equal sign, and you have to have something on both sides. Vertical lines are always x equals. Domain of any quadratic is always everything. That's going to be a super easy question in this unit. The range depends on the vertex. In this case, our range is our y values are bigger than or equal to -8. You can write it that way, or you could write it in interval notation. It starts at -8 and goes up to infinity. And we use a square bracket for the -8 because the -8 is included. So this is how you would graph if you haven't learned any shortcuts. And the rest of this unit we're going to learn shortcuts because a table of values is a bit annoying. Especially like we were doing well, I felt like things were going well, but then we kept going in the wrong direction. Right? We needed to go to the negatives to find the symmetry. But you got to see an amazing jump, so that wasn't it? Worth it. Yeah, definitely worth it. Okay, questions we can circle here. 4, 5, and 7.